this
I get three questions for you. First of all, there are cat people, there are dog people. Please, cat people, raise the hands. No, no cat people. Okay, and maybe don't stop. Okay, I'm sorry, but we have quite some cats here. My third question is, do you know what hyperchains are? Okay. Oh, yeah, so I guess I don't have to explain, but for you who don't, basically hyperchains are a way to own your own independent network, having security stay in protocol. And it derives its security from another blockchain that is called Hyperchain, that should be proof for. So it's a way for you to have your own running blockchain without depending on another. So, what we're going to talk, I hope you can see that. We'll be talking about the problems we're trying to solve. I'll tell you how we can adjust the protocol for your Apache and how you can write your own consensus algorithm if you want. For this, we'll be using cats. Sorry, I should spell it on my account. And we have a use case for their PNF, P1 fish. So that's a hotel service for cats. Everyone can register and provide space for cats, so cats can be office. And since this is your business, that's you probably know me. You later on may decide that you want to pivot and change your business ideas, so you can keep that right yourself. So you're building a blockchain project, and you want to focus on decentralization, trustworthiness, and maybe, if you want to keep it censorship free. Sometimes being your business, you might want to remove unwanted content. So let's imagine you're building a PNF and someone starts selling guns there. So you want to censor that. So the problems. First of all, you can go and build your software as a smart contract on the project, and then you are at the wheel of other projects. Essentially, you start your own service, and you get that's the icon of CryptoCastle. And suddenly the Ethereum network is congested, and there's no transactions, and pool cats left outside without homes. We don't want that. Then you don't want that for your business. So we say, okay, I'll do maybe a copycat project. I'll start a new blockchain project that is maybe stake, because it's lots of stakers, by the way. So then your business is it suffers all the problems that who stake your project suffer, essentially, and all the risks that they sell. And the same goes if you said to build your own proof of work project, then you need to attract miners, and suddenly those miners are simply not enough. You need more miners. Then your business turns from selling housing for cats to attracting miners, and you need more and more and more miners. And miners tend to centralize in pools, and this turns your project into a centralized project, and you probably don't want that as well. And the good thing is that you have been here and we've learned about Hyperchains. And Hyperchains are going to save the project. So with Hyperchains, you don't need miners, and don't be scared. You actually need miners, but on another blockchain, that is the Hyperchain. And from that other blockchain, you're going to derive your security from. So basically, imagine Bitcoin. You do your own PNF blockchain is going to have the same security as Bitcoin. So, and you don't need to attract any miners. You get that for not free, but the fees you pay on Bitcoin. And since this is your own blockchain, you can decide how to deal with state distribution. Initially, you can go with centralized approach, like this is your project, and you take care of it, and it's all full centralized, and you can slowly decentralize it as the stake distribution is more equal, let's say. Since again this is your project, you can define certain goal variables when the cloud that you can adopt and what you can define. Also, we've implemented a neat approach for abstracting away the consensus election leader process into a smart contract. And this is up to the user to change if they see it, how they see it. So basically, you can write your own protocol for election data to the next device. So what can you adjust in the protocol? Since this is your own project, so you can define a network ID. The network ID is a trivial hash or string that defines a network, and any transaction that is produced for your project, your chain, would be valid for on any other blockchain. So the signature won't match. You can define your name, you can define the name of the chain or the coin, you can define logo, coursing. All this you are able to do in the config. So basically you write one big fat config, and everyone that shares the config is able to sync your chain. The thing is that this config can be difficult to get right, so at the end I'll tell you that never to use it for you. You can also tinker the economics of your blockchain. So it's a brown blockchain, so you can start with initial accounts. So let's say you've done an ICE score, and now you have supporters of your project. You can start the blockchain with their accounts pre-funded in the Genesis account. And you can also start with pre-funded and already included contracts. Why not? So you can put all the contracts you need, what your business needs into Genesis book, and you start ready. You can tinker the bell curve of 2 nodes in the config. You have to work with that. So basically you can say that there are no block doors, for example, or you can have add block doors, so they might not be diminishing. It's set depending on your specific use case. The same goes with the block reward delay. It's currently 100 blocks. You can do 1 or 1 minute. It's I don't know what wants to come handle. There's a PIRA account. You can enable, disable, change, and maybe even increase the percentage of the rewards that goes to the PIRA account. That's your chain. It's up to the same. You can tinker the names, options, and everything that's related. For example, on Eternity Minute, you can have chain names, but in the Meow chain, you can get, I don't know, maybe .del. So you can know which model that there is also. Of course, you can change the microblock interval, so you can have blocks even faster, but this can be dangerous. Because there should be some network propagation. You need time for that. You can change the gas limit, and if you come with neat approach, you can get away with a lot more tasks. So let's say you don't care about decentralization, you are the state plane behind this blockchain, for example. And you run the machine, and you can define the minimum hardware requirements for anyone to jump. So you can have not 6 million gas, but 6 billion gas. So then the size, of course, will grow, and the syncing is going to be much slower, much slower. But that's your blockchain. You can change the minimum gas price if you find any. The good thing is, since this is your own blockchain, you can change the protocol. And you can start from ROM, or directly you can go with sets if you want. What is furthermore, you can write some codes. You can include new transaction types if you want to. can change the behavior of some transaction types, if that's your thing, or do whatever. It's up to you to decide to have all the freedom again. But this was not part of the config. You have the freedom to choose a parachain, and that's not a trivial task. The different parachains come with different security implications for your blockchain. So Bitcoin having the most mine power in the world is probably the safest. But then you have to pay transactions on Bitcoin, and that might get expensive. So it really depends on the balance you want to strike between security and cost effectiveness. Now, currently we already have those three supported as connectors, so you simply write in the config that the parachain node lives here with the address, and that this is, for example, alternative mode, or it's a Bitcoin node, and the code catches on their own. If you want to write your own connectors, you're free to do so. They're quite trivial. And you can change the consensus. So the consensus algorithm that collects the data is a smart contract, and you have to provide just a few functions, and you're ready to go. You can make it as complex as you want, but bear in mind that on every key block, this contract is going to be called for every node that responds, if you align them maybe twice. So the smart contract is written here, and you can literally create it here. You can there are a lot of different ideas, and I don't want to spoil the surprise ones that are implemented, but you can really get creative here. You can do a round robin, or you can say that Alice has been around for so long that she gets 10% increase in her staking power just for being around for now, or had done something bad, so Bob is being punished. It's a thrill. We do provide example contract that comes with neat approach for rewards distribution and delegated proof of stake contract with staking pools and possibly many of the things you likely need. And it's actually a set of 3 contracts and a contract factory, blah blah blah. You don't need that. And you can go as simple as set of 7 functions. And the first 2 of those functions are quite close. The only difference is that the first one updates the state, and the last 3 are just getters. So you need just a handful of functions, and you can write your own contract that collects the data. But this can be dangerous, so you better know what you're doing. So now let's see what happens with our meow chain. So of course we're going to call meow chain, and it's going to have the meow coin, and you can put your cat on below, because you love cats, right? And you can adjust the micro-block interval so they'll be tiny, and you get really fast confirmations. This won't result in problems, but you're going to discover that later on with microforks that are going to happen in your chain. Still, your project has been supported by some people, and you see the initial bounce with their initial bounces. You can create your book me hotel for my cat contracts in the C, in the Genesis block, and you can disable all other contract creation. So anyone that joins because it's yours, your meow chain, they can create a contract for, let's say, dog food, because why? This is meow chain. So you have certain control over what can be available on your blockchain, especially with regards to prohibiting integration. And you decide that we want smaller block works, for example. Some time passes and you want to do a backward because you change your goal of your business. And you can do that because this again is your blockchain, and you decide that it's capital back. and you want to add new contacts. So now it's not just capital hotels, but capital doctors as well. And the contact there is slightly different. So you need a new set of contacts that you want to include in the blockchain. Or you can decide that now the network is mature and you want to open contact creation again. Why not? Or maybe raise the gas price. Say. So how do we do that? We already have one like tool for config generation, and it simply asks you a set of questions like how do you want this blockchain to be called, and it guides you all the way and produces the configuration file for you. But then this configuration file will start with how you distribute it to your peers. So having this file, they'll be able to join our chain. We are working with regards to Kubernetes support. That the green thing is a battery. So the case would come with batteries included, and you'll be able to locally test and see how different tooling is playing with the Hyperchain chain. Essentially, you write a single command and you have a node, make account if you want to wallet, just get it for you. What was it? Middleware, Explorer, Faucet. I might be missing something, but it can you get the whole ecosystem out of the box, and you can really play around with it. This is not ready yet. Once it is, we'll announce it on the forum. So, now we will do the moon, and do you have any questions?
So, yeah, thank you very much for your talk. Other questions? Yeah.
So my question is, how possibly in your website is out the activate work, but I know it's sort of either this presentation or if it gives us that's not our so. Did you
Yeah, that's a good thing. Okay, so we use the Pine chain in this example as a ledger or a snapshot machine. We take the hash from the blockchain, Jiao chain, and let this data holds with their account on the Pine chain, saying that from my point of view, this is how the Jiao chain looks like. This is the state of the Jiao chain. And then depending on the commitments, we call those commitments. Like I commit my state essentially to that hash particularly. And then we gather those and based on each state that participated in this voting, every vote on the pie chain grants them the right to join the election voting decision. And depending on the stake and the subsequent from the pie chain, we elect the next leader. So that's how we elect leaders, and we also use the bank chain as a snapshot machine. And this provides us with security essentially. Because if the bank chain is not reorganized, you cannot change the leader on the Jiao chain. So the more secure the parent chain is, the more secure the Jiao chain is. So that's. But the details here can be really different. All this is implemented in a Sophia smart contract. It's quite a tiny smart contract. The election part is like maybe 30, 40 lines. So you essentially get a list of commitments and you decide what to do with them. And you might decide that your particular blockchain doesn't want to accumulate, I don't know, for difficulty like that. But in given mechanism. And you can implement all this in Sophia. So you can live with much less screens. That's one big optimization for us. And you can say that you can change logs, and it's all in Sophia, and you can know eternity, and you want to build on top of eternity stack. Sophia should be easy time.
And lots I think that the main chain, right? So I'll have you here with your planning or that.
So eternity has one hidden gem. Yes, this is built on top of eternity style. And basically, this is eternity with a different consensus mechanism. So everything that's working on top of eternity will be here. But who gets with here is different. And eternity comes with protocol called Bitcoin energy, which divides the who is the leader and which transaction leader this leader is moved in a particular block. So basically, we have a magical block that is called key block, saying that hey, I'm the leader. This proves that I'm the leader. And currently in mainnet, that simply provides a solution to the proof for program. And in the Hyperchains, it provides a signed message saying that yes, indeed, I possess the private key for this public key that the staker that had been hacked on the lottery session. And once you are the leader, you can produce the second type of blocks, which are called microblocks. And they don't require proof for proof of stake anything. Simply you sign those messages and say, this is included in the blockchain. And they are simply routers of transactions. So we get a leader, and until the next leader, this new leader can produce microblocks. And every microblock can have test transactions. So microblocks are issued on demand. So when there is a bad demand, we have more microblocks. And if there is no, we don't simply publish any microblocks. So once there's something to be included in the blockchain, we do get elasticity for that. And this is the same with Hyperchains. Once there is a leader, the leader can use microblocks as long as they're leader. Once there is a new leader, the new leader takes over. At the current approach, the relation between the parent and child chain is 1-to-1. So once there is a new block on the parent chain, there is one new block on the child chain, one key block. Then once there is a new block on the parent chain, this triggers creation of a new key block on the child chain. But between those two key blocks, can still have a lot of long blocks. This is the organization that is being discussed to have not 1-to-1, but 1-to maybe essentially.
Yes, but maybe one is wrote the last one to check out is or the main interest of one set. So you have for
Yeah, but the details here are really old, and will be further explored this in the future. But this, so Pi already provides you with the tools to help your chains hormone classifiers, which is great.